Hi everyone, Assalamualaikum. In this section, we will discuss applications of first order ODE. Okay. In our syllabus, we have 5 applications of first order ODE. The first one is population growth and bacterial colony. The second one is radioactive decay, followed by Newton's law of cooling, mixing problems, and Kirchhoff's law. Right? For the first 3 applications, okay, this is under separable differential equations. Okay, and then the last 2 applications, we use linear differential equation. In this video, we will discuss population growth and bacterial colony. Right? Alright, we start with this formula to solve population growth and bacterial colony and radioactive decay. Okay, from dp over dt equals to kp, and then we use separable equation. Okay, so we can show p equals to c e k t, right? Where p equals to population or radioactive mass, t equals to time, and k, if k greater than 0, means it is constant growth rate, and if k less than 0 or negative, means it is constant decay rate. Alright? For k greater than 0, okay, it is for population growth and bacterial colony. And for k less than 0, it is for radioactive decay. Alright? And then if we have term containing doubling time, means we need to find t when p equals to 2 p naught, right? If we have the word triple, okay, means we need to find t when p equals to 3 p naught, okay? And if the word used is quadruple, means we need to find t when p equals to 4 p naught, okay? And in radioactive decay, there is important term we call as half-life, okay? Means that we find t when p equals to half p naught, okay? What is p naught actually? P naught is an original p, or the value of p when t equals to 0. The value of population or the value of radioactive mass when time equals to 0. Right? In this section, we will examine the way that a simple differential equation arises when we study the phenomenon of population growth. Now, look at example 1 from previous semester papers. Right? 200 crabs are placed in a pond that can support a population of 2,000 crabs. After 1 month, the population of the crabs had increased to 500. How long will it take for the pond to reach full capacity? Right? Alright, first, we extract the information and write T symbol for time and P for population. Okay, we are given 200 crabs. Okay, so we can write time T equals to 0, population P equals to 200, right? And then after 1 month, so we can write T time equals to 1 month. Okay, the population equals to 500, so P equals to 500. And then how long? Means we can write time t equals to question mark. Okay, reach full capacity means can support a population of 2,000. So we can write population equals to 2,000. Okay, we extract the information and write T symbol for time and P for population, right? And then we can start from differential equation, alright? From d population over d time equals to constant population, okay? So from here, separating variables t and p, okay? So from denominator dt, we can move to right hand side, okay? And it become multiplication. And then we can move p to left hand side. Then we can write 1 over p d population equals to constant k dt, alright? And after that, integrating both sides, okay? From here, we just put integration sign for both sides, okay? So we can write integration of 1 over p dp equals to integration of k dt, alright? And then we integrate left hand side and right hand side, okay? When we integrate 1 over p dp, it is equals to ln p plus c, but we just put plus c at one side only, okay? Okay, from here, we use formula integration of 1 over x dx, which is equals to ln x plus c. So when we integrate 1 over p dp, it becomes ln p plus c, alright? And then for right hand side, we can refer from, let's say if we integrate 2 dx, okay, constant 2 dx. So the answer is 2x because we integrate with respect to x, okay, 2x plus c. Now we integrate constant with respect to time, okay. So when we integrate constant dt, so we can write kt plus c, okay. And then after that, we need to write population as a subject. So means that we need to move ln to right hand side, okay. So when we move ln to right hand side, okay, so it becomes population as a subject equals to e, okay, e is an Euler's number, the power of kt plus c, alright. And from here, we can separate, so we can write p equals to e the power of kt times e the power of c, okay. We use properties of indices, okay. And then we can write p equals to c e kt, okay. E the power of c, okay, is constant because e equals to 2.718 something, which is constant. So constant, the power of constant will equals to constant. So we can write e the power of c equals to c, alright. Okay, so now we have population equals to ce the power of kt, okay. Then we can write equation 1, alright. Alright, from the previous slide, p equals to ce the power of kt, equation 1, okay. We can substitute t equals to 0, p equals to 200 to find the value of c here, okay. And we can substitute t equals to 1 month, p equals to 500 to find the value of k here, okay. Then we can find the time, okay. So to find c, substitute t equals to 0 and population equals to 200 into equation 1, okay. So from p equals to cekt, equation 1, so we replace p equals to 200 equals to ce the power of kt, we replace t equals to 0, okay. So 0 times k will equals to 0, alright. So e the power of 0 equals to 1, okay. Then we have C equals to 200. Alright? And then from here, we substitute back into equation 1. Okay? So we have P equals to, we substitute C equals to 200. So we have 200 e the power of kt. Right? Then we name as equation 2. Alright? And then to find K, substitute the second information, T equals to 1 month and population equals to 500 into latest equation into equation 2. Alright? So from equation 2, P equals to 200E, the power of KT here. We replace T equals to 1 month and replace P equals to 500. Alright? So we have E the power of K. Okay. We can move times 200. We move to left hand side. Okay. So we have 500 over 200. Alright. Then we simplify. So we have E the power of K equals to 2.5. Okay. Now we want to find K. So we need to move E to right hand side. Okay. When we move E to right hand side, okay, we get K equals to ln, okay, 2.5, right? Then we can use calculator, okay, so K equals to 0.91629, okay, up to 5 decimal places, right? And after that, we substitute the value of K into equation 2. Okay. So we have P population equals to 200 E the power of K, the value of K is 0.91629 and then T. Okay. Then we name as equation 3. Okay. So we replace K equals to 0.91629. Okay. And then we name as equation 3. This is the equation or the expression for population at any time t. Right? From the previous slide, we get an expression for the population at any time t is given by P equals to 200 e the power of 0.91629t and we name as equation 3. Okay. Then we can substitute the third information into equation 3. Alright. Okay, substitute T equals to question mark, P equals to 2000 into equation 3 here. Okay. Okay, so from equation 3, we replace P equals to 2000. Then we want to find the value of T. Okay. So we can move 200 to left hand side and it becomes 2000 over 200. Okay. Then we simplify. Okay. So we get this. Okay. We want to find the value of T. So we need to move E to right hand side. Right. So when we move E to right hand side, okay, it becomes 0.91629t equals to ln 10. Alright. And then we can solve using calculator. So t equals to 2.513. Okay. From the given question, t is given in month. Okay. So we can write t equals to 2.513 months. Right? So it took 2.513 months for the pond to reach full capacity. So this is the final answer. Right?